Welcome to everybody of you. My channel name is Biddut Flow. তোমরা সবাই কেমন আছো? আমরা আজ নতুন একটি চ্যাপ্টার which is known as magnetic properties of a material. বাংলায় বলে পদার্থের চৌম্বক ধর্ম. This chapter will be finished in one shot only, which is based on JEE IIT preliminary level. Number one problem written in the board. A magnetized wire of moment m and length L is bent in the form of a semicircle. So bent in the form of a semicircle. The length is L. Of radius R. This one of radius R. Then its negative moment. Now we know M equals to M into L, where M is the pole strength. It's a magnetized wire. Suppose this one is of length L. We know it. It is a very easy problem for the base of joint IIT. So if M is the pole strength, here also M, then magnetic moment equals to M times L. We know it. So here, and suppose this is S and this is N. This is S pole and this is N pole. Then direction of this along the SN direction, because magnetic moment is a vector quantity. So here, if this one is added, then twice R. So now magnetic moment will be M into twice R. Now R is related to the semicircle as L equals to pi R, because total periphery of a circular wire is total circumference of a circular wire is twice pi R. পরিসীমাটা twice pi R আছে, তাহলে অর্ধ পরিসীমা কত হবে? pi R. So essentially we can write R equals to L upon pi. So put here we can get M twice M, R equals to L by pi equals to twice, put here M value twice M by pi. So M dash equals to twice M by pi. So answer C. This one is question second. A bar magnet of magnetic moment 0.96 ampere meter square. The unit of magnetic moment ampere meter square. We know is kept horizontally with its north pole pointing towards south. We know this one is the north, south, west, east. So a bar magnet, when suppose this one is bar magnet, it's kept horizontally with its north pole pointing south. So this one is the north pole of Earth and this one is south pole. So the lines of force goes from north pole, from south pole to north pole. We know for a magnet, suppose this one is S, this one is N. Lines of force inside the magnet goes from S to N. And this one is total is a Earth as a huge magnet. So lines of force will go from S to N inside the magnet. Here is Earth. So lines of force going from S to N. And here this one is S pole and this one is N pole. So the neutral points will be obtained at the axis of the magnet. What is the neutral point? In this point, suppose here is this two neutral points will be such that at this point the magnetic field due to the bar magnet and Earth's horizontal component of magnetic field both cancelize each. You know it at 12th standard, we know it. So first we have to write down the expression for magnetic field at the axis. We know this one as B equals to mu 0 upon 4 pi. It will be deduced after this problem for your revision process. Mu 0 4 pi twice Pm this divided by dq, where d is the distance from and this one is the middle point from this one is distance. This one is the d distance. So here we get as we get d cube equals to So the answer is the A answer is the correct one because put mu 0 as 4 pi, 4 pi into 10 to the minus 7 SI unit, and by this we get this. So answer A is correct one. A neutral point is, we have to go to check up the answers B, C, D. A neutral point is located at a distance 0.4 meter on the at the perpendicular bisector. There is no neutral point in this case. For the case when bar magnet is placed north pole pointing north, যখন দণ্ডচুম্বকটা নর্থ পোল উত্তর মেরুর দিকে দিক করে বসানো হবে হরাইজন্টালি, অর্থাৎ ভূমির সাথে সমান্তরাল ভাবে, তখন আমরা লম্ব সমদ্বিখণ্ডকের দিকে আমরা নিউট্রাল পয়েন্ট অর্থাৎ উদাসীন বিন্দু পাবো। এখানে অ্যাক্সিসে পাবো উদাসীন বিন্দু, we know it already at the 12th class how this one is obtained from deducing from drawing the lines of force here. So this one is correct, incorrect one. There is no neutral point on the axis of the this one is incorrect one because neutral point will be obtained on the axis. There are no neutral points on the bisector. This one is also right one. So answer A and D. The previous problem solved by the relation as mu 0 upon 4 pi twice Pm upon d cube equals to D, where Pm is the magnetic moment of the bar magnet, D is the distance from the central point of the bar magnet. So we can write suppose this is a magnet. We are going to find the magnetic field at a point axially. Suppose this is S and this is N. This one is the axial axis, which is known as magnetic axis. চৌম্বক অক্ষ বলে বাংলাতে। এখানে দেখতে পাচ্ছি suppose at point P we have to find the magnetic field at point P. So at point P, if a unit north pole, by definition, if a unit north pole is placed here, then the force produced at this point P, due to this point and this point, due to this pole and this pole, is called resulting magnetic field of this point. So we can write here when a north pole is south pole, so this will repel it in this way. This will be obtained. So F1 is mu 0 upon 4 pi m into 1 is divided by P S square. And this is the distance between these two, you know, from the previous year, that is 12th class. Because this is of joint IIT level, so we deduce this problem as what said earlier. And F2 for this point N we get in this way. Force of attraction for this, because here is a south pole, here is a north pole. So force of attraction here is in this way, force of attraction. This one is the force of attraction for this, and this one is the force of repulsion for this. At the second case, force of repulsion. At the first case, force of attraction, because when there is a unit north pole is introduced, axis or the axis of the bar magnet, then for S pole we get force of attraction because positive charge, because positive pole, because south pole attracts north pole, and in this way for the north pole it will get a force of repulsion. This divided by Pn square. Pn square. Now this one equals to mu 0 upon 4 pi m upon, and from the midpoint, suppose this is the r. This distance is suppose d. From the midpoint of the bar magnet, from the midpoint of the bar magnet, suppose O. So OP is d. Is taken for our expression deduction, and this one is twice L. Suppose this one is twice L. Total magnetic length বাংলায় বলে চৌম্বক দৈর্ঘ্য, চৌম্বক দৈর্ঘ্য বাংলায় বলে চৌম্বক দৈর্ঘ্য, এটা হচ্ছে twice L. So resultant F will be obtained as, what direction. This will be for which one is PS greater or Pn greater. We know Pn is greater, so F1 minus F2 is the resultant because PS is shorter. So at denominator this one is shorter than this. So F1 minus 2 equals to we get. So F1, what is F1? P. So the force of resultant force will be along this direction. This is not the matter for discussion. We are going to find this as early as possible. So mu 0 upon 4 pi into m 1 by ps square minus 1 by n square equals to mu 0 am upon 4 pi. Ps, what is ps? Ps equals to, this one is L minus, sorry, D minus L. So D minus L whole square minus of D plus L whole square equals to mu 0 m upon 4 pi D minus L D plus L whole square D plus L whole square minus D minus L whole square. This equals to mu 0 m upon 4 pi suppose this one is B, because the for unit north pole, the force for unit north pole is the magnetic field. We know it. Force for unit north pole is called magnetic field. So mu 0 by m, what is this? D square plus L square plus twice dl minus D square minus L square plus twice dl. This divided by D minus L whole square D plus whole square equals to this cut out. So mu 0 am into twice 4 dl upon 4 pi. And what is this? This one equals to this square minus L square whole square. Now this D and this L. So we know D is very greater than L. So D square is very greater than L square. So L square can be neglected. So we can write mu 0 am into 4 dl upon 4 pi d to the power 4. So cutting d cube we get mu0 by 4 pi 2 into twice ml this divided by dq equals to mu0 by 4 pi 2 pm upon dq where pm is twice ml. So the formula is reduced here. This formula was used at the previous problem. An iron rod of volume 10 to the power minus 4 meter cube and relative permeability 1000 is placed inside a long solenoid. Is placed inside a long solenoid. Is placed inside a long solenoid. Wound with 5 turns per centimeter. So this one is given in centimeter. We have to turn it into SI system. That is in meters. Meter. If a current of this is passing through the solenoid, then the rod has magnetized and this magnetic 4 options given here. One for magnetization, বাংলায় বলে চুম্বকন, another for magnetic moment, বাংলায় বলে চৌম্বক ভ্রামক। এই রডের চুম্বকন এবং চৌম্বক ভ্রামক দুটো রাশি আমাদেরকে বার করতে হবে। এখানে আমরা জানি we know chi equals to mu r minus 1. We know chi h equals to this, and which is magnetization. I equals to mu r h minus h. Mu r h equals to b minus h. So b equals to h plus I in SI system, and in CGS system b equals to h plus 4 pi I. This system is not taken here. So for CGS system we obtain chi equals to mu minus 1 upon 4 pi. Because here put here h plus 4 pi chi h. B equals to mu r h. So h common 1 plus 4 pi chi mu r h. So mu r equals to 1 plus 4 pi chi. This one for CGS system, and for SI system 4 pi will be out. So from this we get mu chi equals to this one. We get chi equals to mu r minus 1. Why we write this? We deduce the CGS and SI system separately for writing this relation. This relation doesn't come from sky. This relation holds good from our theory. You know it. So according to problem, chi equals to 1000 minus 1 equals to 999. Now I equals to chi times h equals to 999 into, we know the magnetic field produced at the bar magnet equals to Ni for SI system, and for CGS system this equals to 4 pi Ni. So this one will be out for our case. Our case is taken for B equals to Ni. So N is the number of turns per meter to be calculated. Here centimeter given. So 5 turns per centimeter. 5 turns per centimeter. Per centimeter means 1 centimeter equals to 10 to the minus 2 meter into 0.5. So we can get 999 into 5 into 10 to the power 2 into 2.5. So it approximates because it is about said about. So this one is taken 1000 into 2.5 into 10 square equals to 2.5 into 10 to the power 5. So answer is this ampere per meter. This one is the because this is ampere per meter. This one is the meter answer ampere per meter, and this one is unitless here. So this one is the right. So answer is the answer A. Answer A is the right one. Again, M magnetic moment is IV. So I is here 2.5 into 10 to the power 5 into V given 10 to the power minus 4. So 25 ampere meter square. So B also right answer. A answer A and B. Two identical short bar magnets are kept perpendicular to each other at a distance of twice r. The magnetic moment of each magnet is Pm. Two identical short bar magnet, দুটো ছোট্ট বার দণ্ড চুম্বক যারা একই রকম দেখতে সব দিক দিয়ে. What is the magnetic field at a point midway between them? So these two are arranged in the perpendicular manner pattern. How? Suppose this one is a short bar magnet. Suppose this one is O and this one is O dash. So O dash equals to twice R. We have to find the at distance R. We have to find the magnetic field at point P, which you had OP equals to O dash P. So for this magnet, for this one, we get magnetic field at P. For this one, magnet number 1, magnet number 2. For this one, B2, we get mu 0.4 pi because this one is axial point for magnet number 2. So we have found out the relation which one equals to mu 0.4 pi twice Pm upon d cube d equals to what is the distance between the midpoint and that point. There is distance between the this one is a twice r, so this one is the r, so here this will be r cube and for this point, this one is a perpendicular at the perpendicular bisector point. For this we get b dash equals to b0 by 4 pi em upon r cube. It will be deduced later after this problem. So here BHB, here B2 and this one is B1, suppose. So B2 is acting, here is S, here is N, here is also S, here is also N. Suppose this one is the South Pole, North Pole and vice versa. So for this, the B2 is acting along this direction because this one is short, this one is larger. So B2 and here B1, B2, here is B2, here is B1 and B1 will be along this. B1 will be directed along this because there is a when for this in one unit north pole is introduced here, placed here. So force of attraction along this direction, for this force of repulsion along this direction. So result of these two going into this direction. So now the resultant of these two, we have to find the resultant of these two, which is nothing but b equals to root over b1 square plus b2 square because the angle between plus twice b1 b2 cos of 90 degree because the angle between these two components is 90 degree. So we can get mu 0 upon 4 pi twice pm upon r cube b1 square plus b0 by 4 pi pm upon r cube. This one equals to mu 0 by 4 pi pm by r cube 4 plus 1 equals to mu 0 by 4 pi root 5 pm by r cube. So answer C. Number 6 problem, to find the magnetic field at the perpendicular bisector of a short bar magnet, which I said earlier at the previous problem that the problem answer will be deduced as B equals to mu 0 by 4 pi Pm by d2, where Pm is the magnetic moment of the short bar magnet and d is the distance of the point at which the point at which the magnetic field is to be calculated at the midpoint of the short bar magnet, which is known in other words at perpendicular bisector. The point situated at perpendicular bisector. So at P we get B equals to mu 0 upon 4 pi m into 1 this divided by E s square. If a immediate north pole is placed here, then we get for S pole the force of attraction which is directed here, and for N pole force of repulsion which is directed along this direction. So resultant will be directed along horizontally of the bar magnet. So this one is this, and this one for S point, and for N point this will be, for N point this will be, suppose this one is B1, and for N point this will be 0.4 pi upon Pn square. And suppose this angle is theta, so this one is angle theta, this angle also theta, so this one is also theta, so total angle is twice theta. So resultant B will be obtained as B1 square plus, by law of parallelogram of two forces, we know B square plus twice B1 B2 cos of twice theta equals to mu 0 upon 4 pi m by Ps equals to d square plus L square d square plus L square plus equals to mu0 by 4 pi am upon 1 plus 1 plus 2 cos 2 theta equals to mu0 am upon 4 pi cos 2 theta equals to mu0 am upon equals to mu0 2 am cos theta upon 4 pi d square plus l square equals to mu0 by 4 pi 2m. What is the value of cos theta? This one equals to L upon this. L upon d square plus L square root over d square plus L square equals to mu0 by 4 pi capital M, which one is Pm, this divided by d square plus L square whole equals to mu0 Pm upon 4 pi d2, because d is very greater than L, so d square is very greater than L square. So this one is B, which one written earlier. A deflection magnetometer is adjusted in the usual way. When a magnet is introduced, the deflection observed is theta, and the period of oscillation of the needle in the magnetic magnetometers is T. When the magnet is removed, the period of oscillation is T0. The relation between T and T0 given. So we know T equals to T0 equals twice the root over I by mh, where I equals to moment of inertia. I equals to moment of inertia of the magnetic needle and m equals to magnetic moment of the needle and h equals to Earth's horizontal magnetic field, and T0 is the time period of oscillation. T0 is the time period of oscillation. When there is no magnet used, then this is the time period of oscillation for the magnetic needle, where H is the only earth magnetic field, horizontal magnetic field applied here. When there is a magnet introduced, then if H is in this direction, F is perpendicularly in this direction, then resultant equals to root over F square plus H square, and if theta this angle made by the resultant, the horizontal one, we get tan theta equals to f upon h. So t equals to twice by root over I upon m root over of f square plus h square. So t upon t0 equals to 1 by root over f square plus h square, this divided by 1 by h equals to h upon root over f square plus h square. So t square upon t0 square equals to h upon root over f square plus h square equals to h square upon f square plus h square. Put here f equals to this, we get h square upon plus 1 equals to cutting out 1 plus tan square theta equals to sec square theta, 1 by sec square theta equals to cos square theta root over and cos square theta cos theta. So answer t0 square cos theta. So answer equals to A. This problem, the angle of dip at a place is theta. The angle, বাংলা বলে বিনতি কোণ. What is angle of dip? Angle of dip? If a magnetic needle is placed at any place in the earth and magnetic meridian at that place means plane covering the magnetic needle is called magnetic meridian of that place or at that place. At that case, the north pole of the magnetic needle is inclined by angle theta to the horizontal is called angle of dip. What is angle of declination? At that place, the magnetic meridian and at that place the geographical meridian, the angle between the magnetic meridian and geographical meridian at that place is called angle of declination. বাংলায় বলে বিচ্যুতি কোণ. এখানে হচ্ছে কি, if the angle of dip in a vertical plane making an angle delta with the magnetic meridian, then tan theta dash. Here the problem says a vertical plane which is making an angle delta. At that plane, the angle of dip is theta dash. So we can write down the figure as follows. This is the magnetic needle. This is the magnetic meridian at that place. Suppose this is angle delta. Say the north pole is south pole of the magnetic needle. a vertical plane which is making an angle delta. So here this angle is theta, we know clearly it is the horizontal of this magnetic meridian, and this vertical plane is making an angle delta. So we have to find the angle of dip in this plane. So here h equals to, here tan theta equals to v, suppose this is the vertical component, this is horizontal component in this plane. So tan theta equals to v by h, and here tan theta dash equals to v upon h dash, because here suppose h dash, because v will remain the same, but h dash will be the new horizontal, new Earth's magnetic field or new horizontal magnetic field. So our again h dash equals to h dash equals to h cos delta. H dash equal to h, to put here we get tan theta dash upon tan theta equals to so answer A. Again I am saying the problem delta is the angle of a vertical plane which is not geographical meridian here. Here is a vertical plane rather than the magnetic meridian which is making an angle delta with the magnetic meridian. At that plane we have to find the this relation tan theta dash upon tan theta. At that plane the angle of dip given as theta dash. So by the figure we can find the relation. Answer A is the correct one. A magnetized wire having magnetic moment M is bent in the shape of a circular arc so that it subtends an angle theta at the center. If theta is 90 degrees, then magnetic moment. We know M equals to AM into L. Suppose this is a magnetized wire AB. So length L and pole strength M. Suppose pole strength M. So M into L is the magnetic moment, scalar value of the magnetic moment equals to ML, and it is a vector quantity. We know it was discussed at the previous class. So it is vector quantity and its direction is from south pole to north pole. And here problem says that this one is bent into a circular wire AB, and so this is length L, and so its magnetic moment will be now this. Suppose this is center, subtend angle and angle theta. So now this is, suppose this is radius r. So we can write L equals to r theta, and this one is the so the new m dash equals to am into ab. So what is the value of AB? This one is R, this one is also R. Now when this is 90 degree, then we can write AB as root over R square plus R square equals to AM 2 R square equals to AM R root 2. Now from this we can write R equals to L by theta. L theta equals to 90 degree here. So ML equals to twice root 2. ML equals to M twice root 2 M upon pi. So answer D. A short bar magnet placed with its axis at 30 degree with an external magnetic field 0.16 Tesla. The SI unit of magnetic field is Tesla. Experiences a torque of magnitude this 0.032 joule. The magnitude of the magnetic moment of the bar magnet in joule per Tesla unit equals to this. We know torque tau equals to Pm cross B. In scalar notation equals to means tau equals to PMB sin theta. Tau, so we have to find the PM equals to tau upon B sin theta equals to 0.032. This divided by sin 30 equals to 0.032. This divided by 0.16 into half means into 2 equals to so answer D. This is all about JEE IIT preliminary level for the magnetic properties of materials. The total problems 10 are suggested to for answering in one shot. So it was completed. We shall start next lesson next day. and Vidyut Flow. My channel name is Vidyut Flow. You may subscribe if you want it. Thank you.